The previous videos demonstrated how to use the National Instruments myDAQ device and the built-in software to operate it as a multimeter. Additionally, I showed you how we can connect the myDAQ device to measure the voltage and current from a 9-volt battery across a resistive load. The built-in DMM software was programmed using LabVIEW. While the built-in software is useful as a multimeter, in this experiment you will need to collect current and voltage measurements frequently, about one every 4 to 5 seconds, for an extended period of time, approximately 2 to 3 hours. Using the built-in software is not practical given the time and the number of readings that must be acquired. In this video, I will show you how you can use LabVIEW to develop a program that will automatically sample the current and the voltage, display the results, calculate the power, and save all of this information to a file. Once it's programmed, you may start the program running and step away to let the instrumentation do the data collection. And then at a later time, you can import that data back into Excel or some other software program for analysis. With the myDAQ device connected to your computer via the USB connection, I'm going to launch LabVIEW. And when I launch the LabVIEW programming interface, this is going to be the first screen that appears. The next thing that I'm going to do after this screen appears is I'm going to start a new virtual instrument. So I go up to the File menu and then click the New VI option. You will see that two screens appear. One is called the front panel and the other one is called the block diagram. The front panel is where you will program the interface for the user. This is where graphs, charts, numbers, and controls will be displayed. We will then use the block diagram to program how the user interface interacts with the myDAQ device and displays the data. Let's get started by first programming the user interface on the front panel. For this experiment, I want to display the voltage and current measurements as well as the calculated power that is being provided by the 9-volt battery. To get started, I'm going to go to the View menu on the front panel, and I want to make sure that the control palette is visible. When I click that, I'm going to see a control panel that is displayed, and this is where I can select and place different control elements on my front panel. First, I want to display the numeric values of the measured voltage, current, and calculated power. To do that, I'm going to go over to my control panel and I'm going to expand the palette related to numerics. When I do that, I'm going to see a number of different options that I can use to place on my front panel. I'm going to start by placing 3 numeric indicators. So what I can do is grab one of those indicators from the control panel and drag it onto my front panel. Next, I'm going to rename each of these numeric controls to reflect the measurement that I want to display. So the first one I'll rename to be voltage. The next one I will rename to be current. And finally power. Additionally, it will be helpful to visualize how the voltage, current, and power is changing as a function of time over the course of the experiment. So I would like to add a chart to my display, or actually 3 different charts to my display, so that I can see how these parameters have changed with time. To do that, I'm going to close the numeric menu. I'm going to go back to the control panel and open up the graph menu. Under the graph menu, there are a number of different options for types of graphs that can be displayed. Right now, I'm going to choose the waveform chart and place 3 of those on my front panel. Again, I'm going to rename these charts so that I know what they are intended to display. So I'm going to call one the voltage chart, the current chart, and rename the other to be the power chart. I'm also going to expand the size of each of the charts to make them a little more readable by the user. Also, to ensure that all of the data is displayed for all of time so that the x-axis or time scale continuously adjusts to show all of the information that is collected, I'm going to change how the time axis is scaled. To do so, I'm going to come up to the scale of each chart on the x-axis or near the x-axis. I'm going to right-click and then go down to the X scale and make sure that auto scale is selected. I'm going to repeat that for each of the x-axis scales, making sure that the auto scale feature is enabled. With these indicators placed, now I'm going to make sure that my virtual instrument, as I'm developing it, has been saved. I'm going to go up to the File menu and select the Save As option, find a location on my computer, and make sure that I know where it's located so that in the future, if I need to continue development at a later time, I can locate it. I'm going to call this the 9-volt battery measurement virtual instrument, or VI. All right, so now all of my work is saved. The next thing that I'm going to do is I'm going to begin programming using the block diagram. So to do so, I can either click on the block diagram window or click on the window option on the file menu, under the window menu, and click the show block diagram option. On the block diagram, you will see that we have icons that correspond to each of the indicators that we just placed on the front panel. We will wire, or we will program inputs into each of these indicators in just a few moments. But first, we have to determine how we're going to make the measurements and program the block diagram to make the measurements from the National Instruments myDAQ device. First, I'm going to rearrange my icons on the block diagram so that I have a space to work and place the programmatic elements for taking measurements from the myDAQ device. The next thing that we need to do is go under the View menu and make sure that the function palette is displayed. And the function palette is very similar to the control palette that we had on the front panel. This provides all of the different options for programming the block diagram. To program the block diagram to acquire measurements of current and voltage from the myDAQ device, the easiest way to get started is to go down to the Express menu option under the function palette and open that up. We are going to be interested in input from the device because the voltage and current are going to be inputs into the myDAQ device. I'm going to open up the input palette, and one of the first options there is going to be the Data Acquisition Assistant, or the DAQ Assistant. I'm going to go ahead and place one of those DAQ assistants onto the block diagram. The Data Acquisition Assistant is an automated feature in LabVIEW, which is going to ease the process of collecting voltage and current measurements from our instrument. Once we place it on the front panel, you should get a new window that gives you the option of, are we acquiring signals or generating signals? In this case, we're going to acquire signals. The signal that we are going to acquire is an analog input, and I'm going to first select voltage. After I've made that selection, the window will change and it's going to ask where are we going to collect the voltage measurement from. In this case, because we connected the voltage measurement to the myDAQ across the resistors, we selected analog channel 0. I'm going to select A0 as the input that we want to measure. After I do that, I'm going to click the Finish button, and we will get a window displayed here that's going to show the options that we have available to us for configuring the myDAQ. In the Data Acquisition Assistant control panel, I'm going to ensure that the following things are set. I'm making a voltage measurement. I'm going to make sure that the input range is set to a maximum of 10 volts and a minimum of negative 10 volts. My terminal configuration was established as differential. That means that we have two wires that we're going to be using to make the measurement, one as the high voltage and one as the low voltage reference. And finally, I'm going to make sure that my timing settings are set to one sample on demand. This means that the software is going to request that the National Instruments instrument make a voltage measurement. Later, we will look at ways that we can collect data more quickly using hardware timing and running the myDAQ device at a specified sample rate. But right now, we're going to leave this as one sample on demand. Once all those are set, I'm going to click the OK button, and LabVIEW is going to build the virtual instrument for acquiring data according to the parameters that we just set. In many cases, the DAQ assistant can be configured to make multiple measurements, particularly with voltage, so that we can sample multiple voltages from multiple channels simultaneously. However, in this instance, we are, since we're going to make current measurements using the digital multimeter, there are some timing conflicts and difficulties with making both current measurements and voltage measurements in the same data acquisition assistant. So to make the current measurement, I'm going to add yet another data acquisition assistant to my block diagram. I'm going to select Acquire Signals. Again, it's an analog input, and I'm going to select Current as the option. With the myDAQ device plugged in, it's going to give me options of how I can measure the current, and now I'm going to select the digital multimeter as the option. I'm going to click the Finish button. And again, we are going to need to configure how the current is going to be measured. Here I want to make sure that the current measurement maximum is set to 1 amp and the minimum is set to -1. I'm still going to use on demand or one sample as my timing setting. And I can come up here to the Run button and click that and verify that if this number changes, that the device is making current measurements. Once I'm satisfied with these settings, I can click OK. And again, National Instruments LabVIEW will build the data acquisition assistant for acquiring current. As you can see, LabVIEW is a graphical programming interface. We're not going to have to type any code into this. But you do need to recognize that these functions have inputs and outputs. The inputs to the data acquisition assistant come from the myDAQ hardware. We are then going to take the outputs, which will be the data from the data acquisition assistant, and connect them to other functions as inputs to those other functions. To do that, we are going to wire the outputs of the data acquisition assistant to the inputs of the displays that are on our front panel. To begin, I'm going to move my display icons over near the block diagram that's associated with the data acquisition assistant that's making the measurement. After I get those front panel indicators near the data acquisition assistant to which they correspond, I am going to bring my cursor close to the output function of the data acquisition assistant. When I do that, you see that the cursor changes from a pointer to one that looks like a wire spool. When that happens, I'm ready to wire my output of the data acquisition assistant to the inputs of the indicators. I do that by right-clicking, and then drawing a wire between the elements. And I can make junctions by doing the same procedure. So I'm going to wire my data outputs to the inputs of the indicators. Prior to wiring the power indicators, I need to compute power. I'm going to move my power indicators on my block diagram over here, and we know that we're measuring voltage and current. Electrical power that's dissipated by the resistor in our circuit is going to be the product of the product of current and voltage. So the way that we are going to calculate that is by using the mathematical functions that are available in LabVIEW. There are a couple of ways that we can find that in the function palette. It's either located under the Programming tab and the Numeric tab, and we see we have different mathematical operations or operators that we can use. Or we can also find that under the Mathematics tab of the Function palette, again in the Numeric palette. I'm going to multiply these two signals together, so I'm going to grab a multiply function and place it on my block diagram. To better understand the inputs and outputs of a function that we've placed on the block diagram, we can also go under the Help menu and click Show Context Help. When I do that, I will get a small box that is displayed that tells me about the context help. When I then hover my cursor over one of the functions, it's going to give me more information about that function. So I'm going to come over here to the multiply function, and we see that it has two inputs, an x variable and a y variable, and when I wire those two together, the output at the right hand side of the function is going to give me the product of the two variables that we have wired into this. So next, what I'm going to do is I'm going to come up here to my voltage wire, where I'm making the voltage measurement, and I'm going to wire that to one of the inputs of my multiply function block. I'm also going to take the current measurement wire and place that into the other input of the multiply function block. The two of those two signals are going to be multiplied together, and the result will be our power, which I will then wire the output of the multiply block to my power indicator and the power chart. The final feature that I would like to program is a way to take the information that I've collected, the voltage, the current, and the computed power, and place all of that information into a data file that I can then pull up later in Excel or MATLAB and use to calculate other things such as the total energy that's delivered by the battery. To do that, I first need to combine my voltage, my current, and my power into a single signal stream, or a single wire. The easiest way to do that is to go to under the Function palette menu, under the Express menu, select Signal Manipulation, and under the Signal Manipulation, I have the option or the function to merge signals. I'm going to place that merge signal function on my block diagram, and I have three functions that I want to, or three signals that I want to merge together. So I need to expand my signal manipulation merge signals function block to have three elements on it. And the way you do that is you hover over the merge signals function block, and you should get in the middle, you should get a double arrow that indicates that you can expand that function to have three inputs. Now that I've expanded that function, I'm going to connect my voltage signal to the first one, to the first input. I'm going to connect my current signal to the second input, and I'm going to connect my power calculation to the third input. Finally, I'm going to use an express function to save this merged information into a data file. To do so, I can go under the programming menu of the function palette, and then I want to select File Input Output, or File I/O. Under the File I/O menu, there is a Write to Measurement File function. This is going to be similar to the DAQ Assistant in that it's going to automatically configure this function for me after I place it on the block diagram. Here, under the file name, I have the location that I want to save the file. I'm going to navigate on my computer to a location that I want to save the data file, and right now I'm going to select the desktop as the location, and I'm going to call the file 9-volt battery data. And we can say OK to that. Also, I want to configure how the data is saved. I want to save the data to one file only. If the data file already exists, if that same name exists, I want to go ahead and append the information to the file, so it will add new measurements each time to the end of the file. I'm going to go ahead and select the file format as a text format. You can also select the Excel spreadsheet format, but I prefer to make it as a text file. I'm going to have one segment, I'm going to have one header only. And on my time or X value time column, I'm going to select one column only. The data will be arranged in columns, and I want the columns to be separated by a comma so that I can easily import it into Excel or to MATLAB. With all of that information selected, I select OK, and it is then going to build the Write to Measurement file function block for me. The input is the signals input, and I'm going to wire the combined signal output to the signals input of the Write to Measurement file function. We have now completed programming so that we can measure a voltage and a current, display those on the front panel, merge the signals together, and write the result to a measurement file. However, right now, this program will run from left to right, and the data will flow through the system, through the wires, only once. But we want to be able to make this measurement multiple times. So the next thing that I want to do is I want to add a loop into the system, so this will run continuously until we tell it to stop. To do so, I'm going to go back to the programming menu and select the structures menu. Under the structures menu, I'm going to select a while loop. The while loop will run continuously until we tell this process to stop. So I'm going to select the while loop, and instead of dragging it onto the block diagram, I'm going to get this cursor that's displayed, and then I can draw a box around my entire program to place it all inside that while loop. Now the other thing that I need to do is I need to wire or create a stop condition so that this while loop just doesn't run continuously. The stop condition is indicated by this little stop sign that is at the bottom right-hand corner of the while loop. The easiest way to do this is to add a control to the front panel, and I can add a control to the front panel from the block diagram by moving my cursor to the stop condition or the loop condition, right-clicking, and selecting the Create Control option. So this is going to create a stop button, and the stop button will be located on the front panel. So if I switch back to the front panel, we'll see that there's a stop button that has been added to the front panel for control purposes. Moving back to the block diagram, this entire process will continuously run as long as that stop button has not been pressed. Now, this will run as fast as possible, as fast as the data acquisition assistants can acquire the information. But that may result in a large amount of information. So we want to control the timing of this loop. To control the timing of the loop, I'm going to add a wait feature here. So I'm going to go back to the programming menu, and under the programming menu again we have a timing menu. Under the timing menu I'm going to use the wait command or the wait function and drag that onto my function palette. All right. From the context help menu, if we show the context help, we see that the wait function has an input of milliseconds to wait. We need to tell this how long we want for the loop to wait before it executes again. The easiest way to wire something into this is I'm going to create a constant. When I have the wiring symbol on the left-hand side of the wait function, I'm going to right-click, and then I'm going to go down to the Create menu and say Create a Constant. This is going to create a value that will be the input into the wait function. Because it's timed in milliseconds, I'm going to specify that we want to wait approximately 4 seconds between measurements, which would be a 4,000 milliseconds to wire into the wait command. With that complete, now this wait function is going to cause the while loop to pause and not execute again for 4 seconds. So we should obtain a measurement of current and voltage and a computed value of power approximately every 4 seconds, and then write that information to our measurement file. With my program complete, I'm going to come up to the File menu and make sure that I save all of my hard work, and then I'm going to go back to the front panel. On the front panel, again, we have our display of voltage, current, and power, and our 3 plots that shows how this is going to change with time. With my programming complete, I can start the program execution by coming up here to the top left-hand menu bar, and there's an option that says Run. I'm going to go ahead and click the Run button, and we should see that our measurements will occur approximately updating the screen about every 4 seconds. And we're going to see some displays on the graphs. Now keep in mind that the voltage and the power chart as well as the current chart, the y-axis is scaling itself automatically. So right now we're just seeing some noise being displayed from the measurements. Now everything is ready to go and we're collecting data on in our data file. I'm going to connect my 9-volt battery to the circuit of the myDAQ device, and we should see that the measurement values change and we're getting current measurements and calculated power based on the inputs to the myDAQ device. Our charts will continue to track the history of the voltage, current, and power and save that information to the data file. This will continue until I'm ready to stop. So in your exercise, what you're looking to do is to capture all of this information until the battery is essentially drained, until there's little power coming out of the battery and being dissipated by the resistor. This process will probably take between 2 and 3 hours to see some significant drop off in the power. But all of that information will be captured in the data file for later analysis. Once you're done, you can click the Stop button and the program will stop. It will close out the data file and the program execution will stop. With the program execution completed, I should now have a data file where I saved it was on my desktop, and I can take that data file, open up Excel, and simply drag the file icon over to the Excel sheet. What this is going to do is put all of the information from the data file into my Excel spreadsheet. However, it's all going to be located in one column. So the next thing that I'm going to do is I'm going to select this column, and then I'm going to go under the Data tab in Excel, and I'm going to select the Text to Columns option. In my LabVIEW file, I specified that I wanted to save the file as a delimited text file that was where each column of information was separated by a comma. So I'm going to select the comma as the delimiter, I'm going to see a preview down here. I'll click the Next button, and then finally the Finish button, and it's going to separate all of the information that was collected into different columns. Now remember that the first column is going to represent time, and we see that the time increments approximately every 4 seconds. The first column is going to represent the measured voltage. The second column is going to represent the measured current. And the third column is going to represent the computed power. And you can feel free to change those labels as necessary. We can then use this information to numerically integrate the power to determine how much total energy was released from the battery.